Hi guys, for today's lesson we're going to be dealing with differentiation using the quotient rule. So what is the quotient rule? It's a technique used to differentiate functions which contain two functions in terms of x which are dividing. So this is very similar to the product rule, but instead of multiplication it's division. So here is our formula. We're still dealing with v's and u's similar to product rule, but our formula is in a different sort of format. Our u is going to be the numerator of our function, and v is going to be the denominator. So for example, if we look at this function here, y is equal to x over x squared plus 1. You can see down the bottom here we've got x squared plus 1. We've got two terms. That pretty much means that we're unable to cancel or simplify this fraction. So when we want to find the derivative of y in terms of these x's, dy dx, we need to follow this formula here. So similar to the product rule, you need to find four parts for your formula. You need to find u and u dash, and v dash. So u is equal to the numerator x, therefore u dash is equal to just 1. V is equal to our denominator, therefore v dash is going to be equal to 2x, which is derivative of x squared plus 1. Now we can work with our formula. V multiplied by u dash, take away u multiplied by v dash over v squared. Really important that you remember that the u dash comes first and the v dash comes second is my way to remember this formula, because it's really important that you're minusing this one. Okay, v changes to this, u dash changes to that, our u changes to x, and our v dash changes to 2x. And lastly, v squared is going to be our v to the power of 2. So x squared plus 1 all squared. We need to simplify all this. So our top is typically what simplifies. We get x squared plus 1 here, and we're minusing 2x squared. We can simplify this top because we can put our like terms together. So x squared take away 2x squared. That leaves us with minus x squared, and this plus 1 comes to the front. Okay, and notice our denominator, we don't worry about expanding it. So that's going to be our answer. We can convert this to factored form or factorized form by factorizing your numerator. So we can see that this is a difference of two squares. So we get x plus 1 in brackets and x minus 1. So this is a desired form for the second part. So determine the values of x, which dy dx equals 0. So the idea is we want to work with our derivative and figuring out where does this equal 0. So we let our dy dx equal 0. And when we're solving an equation like this, because there's 0 on one side, we need our numerator to equal 0. Because 0 divided by anything is going to give us our 0. So let our numerator equal 0. Let each of these factors equal 0 to solve using the null factor theorem. And we get x is equal to minus 1 and x equals to positive 1. So our conclusion is that at x equals minus 1 and at x equals positive 1, the gradient of our original function is 0, as we were trying to find. Hope this helps with the questions. Good luck.